decompose this into what's known as partial fractions. Now, I want you guys to look back at something real quick. Look at number 5. Number 5, these are partial fractions. Together, this fraction minus this fraction equal to number 1. So I want you to understand, this by itself is a partial fraction. That's a partial fraction that equals this. What we're going to do on number 7 is we're going to break this down into its partial fractions. So what I want you guys to do first is we are going to factor the denominator. I need you to factor the denominator. Now, I want you guys to write in your journal, you're looking for two numbers that multiply together that equal negative 21, and two numbers that add together. Thank you, Noah, for not listening to my instructions. Two numbers that add together to equal a negative 4. All right? By the way, could you please repeat that for me again?
It is negative 7.
Negative 7.
And a positive 3.
Are you positive about that?
I am negatively positive that it is positive.
No, you don't. You should be negatively negative about it, so that because two negatives
make a positive.
Right.
True, yeah.
There you go. So right here, what I want you guys to do is put x minus 7 and x plus 3, which means, bless you, and bless you all who are watching this video as well, just in case you're sneezing out there. Just in case. By the way, all right, so one thing I want everybody to make sure you understand is x squared minus 4x minus 21 equals x minus 7 times x plus 3. Now, understand that this product of these two factors equals this trinomial. Now I'm going to show you how to break it down. Right now, what I'd like you guys to do is do negative 3x minus 29 over, and then put the factors here, over the denominator of x minus 7 and x plus 3 is going to equal a number over x minus 7 plus another number over x plus 3. Plus 2. These right here, this is what's referred to, everybody, as partial fractions. And what we're going to do in this video is we're going to take this expression right here that I'm circling, and we're going to decompose it or break it down into this fraction and this fraction. So essentially we're solving for A, and we're going to solve for B. No, this video is not brought to you by Famous Amos Cookies. Okay? It's not. Even though, thank you, Adam. Thank you, Adam, for buying me Famous Amos almost every single day.
I bet that Adam actually gives me. Yep. So I'm failing a bunch more cookies.
Adam's not failing.
No, he's not.
Thank you.
Yeah, he goes to go back to me better than this today, or he's gonna let me.
Alright, what I need everybody to do right now, every single person, I need you to put a big parentheses around everything. Okay? Everything right here. Now, you're going to multiply this whole equation by x minus 7 and x plus 3. That's what you're multiplying the whole equation by, which means you're going to distribute that to every single part of the equation. So when we do this, what's going to cancel out in this one right here? The denominator will totally cancel out. This x minus 7 will cancel out that x minus 7. This x plus 3 will cancel out this x plus 3. And all you will have left is negative 3x minus 29. That's all you will have left because these will end up canceling each other out. equals, I have an A right here. What's going to cancel out in the second part? No, not no. No is not going to cancel out. He'll still be here. Okay? All right? But what's going to cancel out? What part of the expression? X minus 7. So those will cancel out. So what are we left with? We're left with an x plus 3 plus b times. Here, what's going to cancel out? No. X plus 3's will cancel out. So if we were to take our time and energy and multiply all of this in the numerator, eventually, this is what your equation would be. So now what we're going to do is we are going to solve for A. And then over here, we're going to solve for B. So in your journal right now, I want you to make a nice little column like this. Put solve for A and solve for B, and I'll show you how to do that. All right. Step 1. To solve for A, I want you to plug in a 7 for x. Plug in a 7 for x. Let me show you what it looks like, right? Negative 3 times 7 minus 29 equals my A value times 7 plus 3, and I'm done, because look what happens if you plug in a 7 right there. You plug in a 7 right there, what's going to happen to all of my B value? It becomes 0. So all I did was plug in a 7 so I could solve for my A value. So here's what I have. I have a negative 21 minus 29 equals 10 times A. Because 7 plus 3 is 10. We combine these together, you get negative 50 equals 10 times A. And my A value will simply, if we divide both sides by 10, my A value would be a negative 5. And we just solved for the A value. So let me review really quick what we did. The reason why we plugged in, everybody, the reason we plugged in a 7 for x is so that we could cancel out all of our b's and solve for a. Now, what I'm going to do for my first step to solve for b is I'm going to plug in negative 3 for x. And look what happens when you plug in a negative 3 right here for the x. What's going to cancel out now? All the a's are going to disappear, and we can solve for b. So let's go ahead and do that. So here's my equation. I have negative 3 parentheses. What am I going to plug in for x? Negative 3 minus 29 equals, I'm not going to put any a values because I know if I plug in a negative 3 right there, it cancels out to a 0, equals b times negative 3 minus 7. Negative 3 minus 7 is a negative 10, so this becomes negative 10b. Negative 3 times negative 3 is 9. 9 minus 29 is negative 20. If I divided both sides right here by a negative 10, what is my b value equal to? 2. Now, I'm not done with my final answer, but I did find what? I did find a and I did find b. Now we're going to take these and use them to build our partial fractions. So I'm going to scroll up here so you guys can see our partial fractions. You should have them in your journal. This is one of my partial fractions. This is my other partial fraction. This a's over what? X minus 7, b's over x plus 3. So here's my final answer. I'm going to put a negative 5 over x minus this right here, this answer, if you added those two together, if I said we're going to add these together and find the expression that's simplified, okay, these two answers together would end up equaling what we started with right here. That's what your final answer would be. So what we're doing is learning how to break down these type of rational expressions into their partial fractions. And these are the partial fractions for number 7. Okay? I want you to use this technique to solve for number 8.